Now, to get the direction of motion of the particle P, which is in this direction, as a bearing, what we've got to do is set up a north direction. So we set up north direction like this, okay, through here. And as a bearing, you've got to start from facing north, turn in a clockwise direction until you get to the direction that you're going in. And so this is the angle that we want round here. And to get this angle, what I'm going to do is work out what this angle in here is. Let's call it theta, say. Once I've found that angle, I'm going to do it by trigonometry. I can then add it on to 3/4 of a turn, which is 270 degrees. Add it to theta, and I've got my answer, the bearing. Okay, so let's start by working out theta. What we have is that the tan of angle theta would be the opposite side over the adjacent side, so that would be 8/5. If we inverse tan both sides, we've got theta equals the inverse tan of 8/5. Do that on a calculator and what you get is 57.9946 and so on degrees. So therefore, when it comes to the bearing is going to be equal to 270 degrees. That's, as I say, 3/4 of a turn to the dotted line, and then plus the 57.9946 and so on. Do that and you'll find that you'll get 327.9946 and so on. That's in degrees, and we've got to give it as a normal bearing. And bearings are normally measured to 3 figures, so 3SF. This is going to be 328 degrees to 3 significant figures. Alright, so that brings us now to the end of this part of the question.